All right, so in preparation for our tests that are forthcoming, there's a $20 word for you there.
$20?
We need to cover a few specific topics before we get there. One of which would be the equation of a circle that we started talking about last week. One of which would be arcs, chords, and that information. Focus and directrix of a parabola, a few different things. So for this week, we're kind of jumping around to fill in those gaps, and it was going to be too complicated for me to assign you questions from the book for your homework. So your homework is essentially going to be this worksheet, but especially because the copier sucked, well, really the resolution on this test generator sucks. The copier is doing its job just fine. We're going to go through that together before we get out of here. Before we get to that, though, we want to make sure that we have some learning. Now, those of you, just like Lauren, who are upset about your Math 1 peers doing some work that you don't know how to do, you are absolutely correct. What has happened here is Ohio has moved, and I think just like everybody, but our standards have shifted some of this circle work down into Math 1 out of Math 2. What that means for you is last year when you were a Math 1 student, you should have learned this in Math 2. This year as a Math 2 student, you should have learned this in Math 1.
Wow.
You are caught in the transition year, which means you have content we need to squeeze in that next year the group won't. So I need your attention, I need you to work with me, and I need you to tell me when you have questions.
This happens. It's like next year you get to go to King Island, and then next year, the last year gets to go to King Island. It's just like,
your school doesn't have enough people, so we're going to move you to Kilbourne.
Draw a few circles on your paper.
Yeah.
did you say circle?
Circles.
Circle.
Wait, so that doesn't matter.
We can't make perfect circles.
Oh, yeah, I remember that.
They have to be perfect.
Yes.
Welcome to my world. I like KMS.
I guess I'm dying.
KMS instead of what? KMS.
Perfect. This is perfection.
I found circles.
Yeah, water bottle.
To go to, what's it called? What was the thing that you did instead of wait for Oh, you have to pay $20.
Okay, so first things first,
Oh, yeah.
and there's a couple questions on the worksheet about this. On a graph.
That is amazing.
Yes, way off. X minus h squared plus y minus k squared equals r squared when we have center hk. So with parabola as an absolute value, we had to flip our h, right? Because we had x minus h, but then we had plus k on the outside. Here we have to flip both.
Wait, what?
So if your center is 2, 3, positive, right? Positive 2, positive 3. The equation ends up becoming x minus 2 squared, y minus 3 squared equals your radius squared. So the h and the k value, when we put them into the parentheses, will look the opposite of what they are. So
Radius is that kind of function.
we look at what the radius is, and then we figure out what that is squared.
Oh.
So it depends on if we're given the equation, trying to graph the circle, or given the circle, trying to figure out the equation. So if we have something like this, h is your horizontal, pretty straightforward, but k, don't ask me why, is your vertical, and then your radius, you know what a radius is. Questions? H, K, radius.
V, that's weird.
Probably because it looks like other things, and K is more unique. I just calibrated this morning, too.
How much does it matter?
Man. I mean, you have to pass it to pass Math 2, like the class.
But like, we're going to pass it.
Yeah, I've never had a kid not.
Probably shouldn't have.
We're different.
Times for a year.
All right, now skipping. Way. This is the wrong window. Wrong window.
Correct.
Kind of.
Hey,
There we go. They're round and they have weird parts. Alright, sounds great. Everything you need to know about circles, they're round.
Your genius. They are.
Let's just label some pieces of a circle. So we need to make sure that we understand what we're talking about before we start defining things. A part of our circle on the edge, which we should already know this, is an arc.
Yeah, Steve, you said a arc. It's an arc.
Really?
I'm sorry. It's anarchy.
Any
Communist anarchy.
Steve and I was not that funny, I promise.
That was really fun.
It's a government type technically.
Sorry, I meant for that to be read. Is a chord. Now, I think we know this, but I don't want to make any assumptions.
Major or
For
minor?
a line,
No, definitely.
that yellow would be minor. Sorry, if we're talking about arcs, major, minor are defined by less than or greater than 180. Right, so we could also talk about a major arc between those 2 points.
I'm just trying to make a pun off the chord.
No, for real though. Major arcs are more than 180. Minor arcs are less than 180.
Makes sense.
So if it says major arc such and such, you know which way to go. Versus if it says minor arc such and such.
The right circle looks like you're unrolling duct tape.
Sure. So if you think of unrolling duct tape, and this is your tape coming off, we can use that as an example. Now, it wouldn't necessarily have this relationship, but if we make it have a 90-degree relationship with the roll of the circle, we can then call that a tangent line.
Wait, what is the...
Now, here's where people get goofed up.
Which one's the tangent line?
That line. The line. It makes a 90-degree relate, but that line doesn't have to exist. That's just showing it makes a 90
So
degree
that
with the
black line
radius.
at the bottom,
Okay.
like the tape of the...
Now, also though, from that point, there's another tangent line, and I will fix my points over here. I should probably just reorient at some point. That creates another tangent point. I don't know why sometimes it's on and other times it's not. That has a 90-degree relationship.
Can't there be infinite?
Not from one point.
And here's a
It's-
correlation.
Ooh!
It's an ice cream cone.
Or no. Yeah. Same thing.
No one pulled this off yet.
The two tangent lines from a point outside the circle will be congruent.
Whoa.
So even though the diagonal, like when we think of a hypotenuse, gets more distance as it travels, it hits the circle closer in my baseline.
Oh, makes sense.
So any two lines tangent to the circle from a single point on the outside are congruent. And then we also know these radii are congruent to each other. What did we really just make?
And I similar triangle.
That's not a triangle.
Isosceles.
Well, what if you put
What do you mean?
line?
It's a kite.
It's a kite.
Wow! It's an ice cream cone. Don't
It's
you
a
see it?
kite.
Mr. Hudson,
It's an
technically
ice cream
that's wrong because that's that kind of thing says that they're all congruent, but they're not.
Technically, it's still congruent because there's only two lines.
I don't know what else I need to. I need to teach you more, but I want to orient my board. But I need to teach you more.
I mean,
But
orientation.
Time.
To teach. How about we make
Yeah,
an equation?
but-
Orient the amount of time orientating it would take.
Orientating it?
Oh wait, Mr. Hudson,
Like,
can I
sorry.
show up oriented? Mr. Hudson.
No, not if I'm using the mouse.
Orienting?
We should just try
There's
to
other
go
rules
back.
that we need to talk about, but
More.
So like, as long as we don't fail, nothing bad will happen.
If you don't fail, you pass.
Is there only two outcomes of the test?
Well, you can't just like have to sit in limbo for the rest
I mean,
of your life.
you can like just.
I mean, you can get
No,
like
the
really
real
bad
test
score, but
will
still
never
pass.
progress
Let's
past
do
math
it
two.
kill you, but it's not.
draw a new circle.
New circle.
Another
Now, there's all these stories that I could tell dealing with like Eratosthenes and these old mathematicians and things they were doing in the sun and stuff like that, but
Whatever.
we're trying to get through this stuff kind of quickly.
Pac-Man. It is Pac-Man. Now Pac-Man.
It is not
Ninja
Pac-Man.
Pac-Man. Now it's not.
Now it's an angry bird.
It is the Pac-Man.
So, your Math
Now
1
it's my
peers had a whole worksheet dealing with relationships such as this.
Kill it.
Now, if you helped them, or if you've seen these before, if we know that the arc we're intercepting is 40 degrees, what else does that mean we know?
Trying. It's well, it's 1/9 of
It would be 80.
the circle.
80 degrees.
So this is 40 degrees, 40 degree arc that we intercepted.
Looks like half.
The rest of it is 320.
Yeah.
That's how it works.
Is that correct? Is it like the rest of it?
Makes sense.
Ooh, is that,
What is that?
is that 40?
20.
How could that be 40?
That
This
can't
is
be
It's
40.
20.
I don't know, it's half of it.
half of the arc it intercepts. So, here's your circle rule. If given a circle with an arc,
That's being an intercepted, dude.
Oh, I can do like the X thing.
Kindly never repeat that.
Do what intercepted do?
this is z degrees, that's z degrees,
You see.
and anywhere that this point is, doesn't matter if it's there, or down here, or wherever, there is z divided by 2. Yeah, I know, sorry, I should not have used z and 2, that was a poor choice.
Wait, what do you mean?
Yeah,
Where
still
you put it? Like,
This point, if I have straight lines connecting to those, I can slide it around the circle, right, and still make connecting lines up. It's half of whatever z is.
What if it's a major arc, though?
You can't do that with a major arc.
yeah,
You
because
can't.
it has
It's
to
just
be
you
like.
can't do it. Well, no, we could. Only for a certain amount, though.
It would
But
just be a
it
triangle.
still works.
It'd just be a triangle.
So here, let's try it. But I answered too quickly before I actually thought. Major arc. Right, so let's say from here to here, but the major arc, if I put a point here, I can connect chord there, that angle will be half of whatever this arc is. Now this brings up an interesting question. If I make a circle and I draw you a diameter,
Make it like 1,000 miles.
and I ask you to put a point on there. Let's say, now this one is out of the textbook, I can't take credit for it.
Mr. Hudson, why wouldn't you take credit for your work, though?
He didn't make the text.
Yes, he did.
Yeah.
That doesn't quite look like a diameter.
What if, yeah, I know, it probably should be shifted up.
Wait, what's that? Is that an angle sign?
Yeah, angle ABC.
Okay, that looks like a.
So what if I put
Why are there so many B's?
B there, or B there,
The angles are going to be the same.
What the B?
or B there,
The angles are all going to be.
It
They're all
looks
going to
or
be
B
the same.
there?
B.
It looks like a crown.
Be the same.
That's actually pretty cool.
They're going to be. Alright.
Okay, it's time to stop. But, well, gamer time.
Why?
Why would that?
Diameter than the angle on the line.
the arc, all those chords,
Oh my.
they all use the 180-degree arc. They all use the same arc. So two angles utilizing the same arc will be equal. Now we get into some more interesting relationships in the chords. Now I might just have us start looking at your worksheet to deal with these interesting relationships.
Wait, so we're not doing text?
Kind of. I'm trying to teach too much to just go straight through the textbook.
How come they just don't test us on the, like, why are they testing us? Something that we shouldn't learn, that we didn't get a chance to learn?
Satya, I already explained this.
Yeah, I know you explained, like,
Look at that guy right there. Looks like he's putting his hand in his mouth.
That was Eratosthenes.
not anymore.
Draw a new circle.
Why are there so many circles?
Infinitely many circles.
No!
Try to draw a couple chords.
Actually, there's only one circle because they're all similar.
Technically,
Draw a
that
couple
doesn't mean
chords.
There's only one. That just means they don't.
It's the Smash Bros. symbol.
Yeah, it is. It's the smash ball.
It's Smash time.
Smash.
Guys, this is some information you don't yet know, so I need you to take that like mindset of I actually need to care about what we're doing. No, I'm not a fan of April Fools at school. You should be able to trust your teachers and what we're doing. We are just continuing to learn.
We didn't actually need to learn this today.
Just whips out. There's actually no state.
I wish.
Wait, are those? Oh, never mind.
Maybe school
Now,
is the-
this creates a really weird relationship that it's taken me a while to make peace with, like in my head.
I'm guessing it's. Wait, that could be.
Let's hypothesize some relationships that might be able to exist. Now, when I first started investigating this, like, let's say I'm in your shoes, first thing I might think is, are two chords always going to be equal? Or something like that. Well, no, because I can draw one that would be the diameter, and I could draw another that would be, like, real small. And they could intersect, right? But they wouldn't. Crap. So, what if I tell you, something smells really good. What if I tell you that there is a special relationship between intersecting chords that always holds true?
Wait, is it? It's question mark 3.
Question mark is EC.
Wait,
Sorry,
so
no, it's right.
BE
Now we're in length.
BE6.
BE is 6. Yeah, EA is 4. I just wrote down the info. It's in 76.
Is EC 3?
How are you? Like, what are you basing that guess off of?
Is
Oh,
it
8 over.
16 thirds?
What?
EC.
Oh, just like, I remember doing similar, like, not, when I say similar, I mean, like, similar math terms, like, similar triangles, and, like, 8 and 4, and then 6 and 3. And I'm guessing that they're similar, because they're using the same midpoint, or the same point that they base it off of. Like, the ratio.
So this angle
Wait, hold on.
Yeah.
would be equal to this angle.
Yeah, vertical angle. Which would
Hold
mean
on, hold on, hold on. Okay, keep going.
that, and the other two angles would be the same, because it's supplementary.
Wait.
So like
Yeah,
those are the same.
Mr. Hudson.
Yeah. Hold on, he's processing. I often give you a lot of time to come up here.
And then angle D and angle B would be the same. They're proportional to each other. Like if you just like if you could go up there and imagine like cutting this off and then rotating it up here and then making it bigger, it would fit in there.
So they're all circles, basically. is what
Yeah.
you're saying. That's what I was gonna say.
Jacob, you're raising your hand. I'll walk away.
Well, I mean,
And never come back.
I think maybe like
Careful, it's not quite yet.
this is like double what this is, because if you use like the 3, 4, 5, then the distance between D and B would be 10. So this is 10.
He's a genius.
And then this would be like a 3, 4, 5 triangle. Or
So what are we hypothesizing? And actually,
They're
Thomas said this a
similar.
while ago.
Um,
Yeah, but what does that mean then? If they're similar, then
They're
5.3.
that similar doesn't mean congruent.
Same angle.
Okay, angles are congruent.
Angles are implied by similar.
So we have similar. If they're similar triangles, we then end up with similar.
Chords?
No.
Areas.
Similar and similar size.
Yeah, arcs.
But that was
Similar ratios, right? So we can set up similarity ratios because we have similar shapes.
then yeah.
So our
No.
longer side, right, longer leg, so DE, if I start with longer leg, DE over shorter leg, BE, longer leg, are we guessing AE?
Sure, why not?
I don't know why I did that.
Ooh, E is very important.
That's because it's the point of intersection.
It's like the number 12 in Spanish.
Wait, what?
You didn't do the number on
Yeah, it's gonna have to be 3, right?
Completely blows mine.
Now wait, let's test this. Is 3 compared to, sorry, not 8, because we already did something like that. Is 3 compared to its total length of 11 equal to 4 compared to 10?
No. Ain't it cheap?
Wait, so that would be part to whole.
Wait, what do you?
Well, no, that wouldn't be right. It would have to be 3 to 11 and then 6 to 10.
Why
Or
won't
not
this
6,
hold
no.
true?
Because 4 got the
What
short
did we
side.
already say?
Chords aren't
Chords,
similar.
They're not actually
They're not the same for each other.
chords aren't equal, therefore we're taking a part to whole comparison, and
Ain't.
chords aren't equal, we're not using that
We
comparison.
do part.
So what we're saying is just part to part, to small part to big part, small part to big part.
A big part to big part, small part.
That worked here. Find a problem in your homework packet that involves intersecting chords.
Found it.
Oh, where?
I found
2,
one.
4,
2 isn't 1.
6,
12.
6.
7,
12.
6.
9,
Oh my
Dang
goodness.
it.
This is like literally. Look at 6. It's just the same.
Hold on. Wait a minute.
So
That's different lengths, I think.
AE is 3. A D, be careful,
Yeah, that's the entire thing.
is 12.
Oh.
BE 14.
And nothing else. So you can know that ED is 9. 3 over 14 and then something over 9. 14 over 9.
You know, yeah, 14 over 9
Equals
X
3 over
3.
What?
I think it's X over 3.
No, the okay. 14,
Yeah, 14 over 9 equals x over 3.
yeah, X over 3. So,
So 9x equals 3.
what's 14 times 3?
Or no.
13.
No, it'd be 3
divided by 9.
It'd be 3 over X.
So I was right. The original.
So this is a really good justification kind of picture of as E moves, the relationship between them changes, but always we're going to have 2 similar triangles because the arcs that they use. Because if you want to relate the other angles to each other, and you maybe saw this off the other one, but if you're still sitting here having any issues with this, I'll get close eventually. This compared to this, so A has to be equal to B. I don't know how this part of my smart works so off. Same thing with D has to be equal to C. Vertical angles, E has to be equal to E. Has to be similar triangles. So those similarity ratios of these side lengths hold true, but be careful trying to compare part to whole. That is not what we do.
Are all
Part to
four-
part.
Are all four triangles isosceles?
Isosceles. We
Well,
didn't say
that.
they're necessarily isosceles. We're not, unless we know they're isosceles, we don't know.
Oh.
Yeah. They might be, they could be, but we don't know that. Cool.
Like we can draw some really weird.
Yeah, you can create some really cool relationships.
Incorrect things. Satya.
So are we good with 6?
No.
Well, is the answer 27 over 14? Because if it is, then yes. But if not, then no.
27 over 14 is 9.
So, check this out. Everyone flip your packet over. There's answers.
What?
In our...
I was the one who said X over 3. I was literally the one who gave you
Hey,
what we
guys.
should do.
We're all on the same team here.
It's just
In our efforts to make sure that you're comfortable with these skills as we head towards the test, I wanted to give you the answers to really push you to, as you go, check your answers. If you can't figure out why something is what it is, we need to go over it. Okay, so we have today and tomorrow dedicated to circle work. I want to go ahead and give you the next almost 15 minutes to have you just work through this packet and find any questions. You're like, I don't know what I need to know to solve this. Can we not react so loud? So, tomorrow we will continue on circle work, but right now I want you to identify if there are things you don't know, because I'm not 100% sure what we know or not.
yeah, you're right.
Right? And we took 2 different paths to get to this class. So dive in and start looking through those things. If there's something you can't read, that's probably going to happen. Tell me, and I'll put it on the screen so you can copy down what it actually is.
If it looks like a diameter, can we assume it's a diameter?
Okay. It means in circle.
No, that's the
the
chord
calculator.
XV. It wants arc XV.
Wait, how do you
Yeah,
calculate-
be careful with notation, guys. If it has a curved line above it, it's talking about the arc length, not the segment length.
Mr. Austin, can you do number 1?
What?
Calculate the length of XB. Isn't that just-
Offer some viewers.
No, you got
Questions?
calculator.
Oh, there's the arc.
So, here's how I would process through.
Hold on. Hey. Oh, it's just
All right, in the most pixelated manner ever. All right, so we have 40 degrees, we have 9 centimeters. Right? We know that because this is a diameter, this angle's what?
90.
90. So that's the first thing to notate. 90-degree angle. We know that because this is 40 degrees, this is 20. Based off that, we know that this is 70 degrees, and we know how to trig.
Oh wait, it's
We can use proportions.
Okay,
These
never mind.
would also no.
Wait,
Okay,
is
and then
it
you
just
can take out
is it
that
VY just 180 like the arc?
No, we can't.
Vy?
Yeah. It's
Yes.
just 180.
Yep.
So can't we just do 140?
Yes, if you just want degree measure of the arc, yeah.
Adjacent.
They're essentially like supplementary, right?
Oh, it's
Arcs that involve the diameter. are
okay. I
essentially
already know how to
supplementary.
do
Okay. It would be cosine of
Other questions of don't know how to start.
adjacent over. Why am I having to do this?
I really don't know.
Could we just leave her in a different
Did you get for the diameter of the first one? Did you get Vy equals 9.5775? What did you guys get for the diameter of one? Or not?
Yeah, 9.5779.
Okay.
5. No, 9.577599.
I'll give you the area, so pi r squared.
Can we read the degree measures in 9, alright?
Yeah.
Oh, I pressed caret when it already was.
10 pushes your equation of the circle work to deal with some inequalities in C and D. So 10 pushes you to think about some inequalities. By the way, the ones that used to be multiple choice aren't now. So if you want to go on your answer key, 11, what's your answer key tell you in 11? Like flip to the back. It tells you C, right? So go ahead and write down 110 right now.
Oh, what's 12?
You tell me.
D.
12.
Okay.
I got rid of the multiple choice, like just to save you space on the worksheet. So 11's actually 110. 12 is, or sorry, yeah, 12 is actually 12. None of the rest are multiple.
Right on the answer.
What is the length of XV? Well, it tells you it's 9.
What is length of EV?
Alright, then I'm just going to let you guys work for the next 8 minutes. We'll go over this tomorrow.
It tells you the length. What do you calculate?
It
Okay.
It is, but it's no.
No, it didn't tell you the length.
It's